Hey there, all my biologists. Mr. Korb went over what respiration is, and I want to kind of take a little look at what actually energy or chemical energy is. We take it for granted that we eat a cracker and then we can move, but really, what does that mean for um, that chemical energy to be released? And like, really, what's happening? So I think we have this idea of potential energy, right? So if I have a ball, bear with me, here's the ball, and it's up high off the ground. Then when you release it, that energy, there it goes, where'd it go? Under the bench, gets released. And as you could tell, there was some energy as it hit the ground, in sound energy. You could feel the vibrations of the thing hitting the ground. There's heat generated if you use a thermal camera, but that energy was released as that thing got to come to a lower gravitational energy, if you will. This is methane, which is a very simple hydrocarbon reacting with oxygen and creating carbon dioxide and water. If we could, or if we wanted to, we could capture the gases coming off this, do chemical analysis, and prove that it's just carbon dioxide and water. Just like your body burns glucose and also makes carbon dioxide and water. But this process is not happening in your body right now because that would hurt. All right, now I know it's kind of tacky to record a computer screen when you could just screen capture, but here we go. I've included this simulation in the materials for the assignment. But basically, these hydrogen, they're supposed to be hydrogen and oxygen atoms, and we're gonna react them and make water, because hydrogen and oxygen are more stable in the form of water than they are in the form of separate hydrogen and oxygen. You might have heard that hydrogen and oxygen are both explosive because they'll react with things around them. So you notice that the simulation asks you to add some energy to break one of the bonds. So it takes energy to break bonds. And then when new bonds form, energy is released. So to show you that real quick, I'm going to add some energy to break one of the bonds. And as you see, when the new bonds form, they get more energetic. And then that energy is used to break more bonds. The ones yellow have reacted already. And the ones that have reacted, you can see they're wiggling back and forth because now they have more energy than they did before they were broken. The ones still had some, but see how they're bouncing into each other. And on the side over here, you can see the potential energy is going down, kinetic energy is going up. And really, when you digest food, it's very, very similar to that. Much more complicated molecules. The processes involved are very complex. And if you go to graduate school, you can study all of them. But this is on a very, very basic level what happens. It takes energy to break bonds. And then when the new bonds are formed, just like the ball dropping to the floor and we get the crash, when these things crash into each other, they have much, much more energy than they did before. And when you see an explosion or that fire on the stove, that's what's happening. You're seeing stuff crash back into each other, and it's so hot it can emit light, just like white hot metal. In summary, this is what's going on in your body right there. So you take the sugars, and it takes a small, what's called activation energy, to take it to the next step, a little bit less energy. We require a little more input to bring it down a little less energy, a little less energy. The net change is the same thing as if we were to burn the sugar. This is if I add a lot more energy, light it on fire, drops down to the same products. But in your body, obviously you're not on fire. We release the energy slowly over time through lots of very complicated processes that scientists have got Nobel Prizes for discovering. And if you get into molecular chemistry or biology and chemistry, then you will know those things and memorize them, but they're not in the scope of this course. So enjoy, answer the questions, submit them, see us in office hours if you have some questions that you can't figure out, and we'll see you around like a donut.